All right, greetings. So today I'm going to talk a little bit more about exceptions, and we're going to actually look at the exceptions, some of the exceptions that the API provides. We'll specifically look at the generalized exceptions and then also runtime exceptions. And we might look at something else, but those are the two big pools of exceptions, and tries to and hopefully will give you an idea of how to use of the things that that can happen, and how we should probably use them, or expect those things to happen. And then we'll look at using the try and catch. Jeff showed you one style, and then I'm going to show you another style of using the try and catches, and then that'll hopefully be it. And if anyone joins in and has any questions, yeah, go for it. And if you're watching this recording, feel free to, and have any questions, feel free to email me. Okay. Yeah, so everything looks good in Jeff land. Still able to log into the server, his website's up. Hopefully you've started and finished, or at least most of the way on assignment 5. And then I will happily take any requests for sessions if anyone has any. So if you have any of those, just let me know. Okay, so exceptions. So as we had talked the previous session, an example of an exception that could happen is, actually the last 2 sessions we talked about this, when you're trying to access something that you can't, like an array index out of bounds. Either you tried to go negative space, or you went too far, or that you're trying to open a file that doesn't exist, or that you don't have permissions, and you're actually going to see different exceptions to those. Or trying to use the wrong input or arguments can also throw an exception. So let's look at those. Let's throw those exceptions. Like, let's do something that would throw those exceptions. So the array index out of bounds, that's that one's pretty straightforward. So here's an array, making a new array called iArray. We're making it size 10. So the valid indices will be 0 through 9. And then we're going to try to access the 13th spot, and we're going to try to assign the number 5 to it. And so here's us creating the array, and then here's us trying to set it, and then we see this array index out of bounds exception. So that's one exception, and so that lives in the Java lang exception. So array index out of bounds. Okay, and so that was the first one, and then the next one was file does not exist, and then we'll do no permissions to read. So we're going to need the let's try to open with the scanner a file. So we're going to need to import the scanner and path. Path allows us to open the file. And then we're going to try to open something in temp test. And so here we go. We have this no such file exception here. So let's go and create that file. So I can say, I just say touch that file. Now, if I was to try to make it, no problem, all good. But if I was to say chmod, this changes the permissions. 000 essentially removes permissions from everyone. So this is from the owner, or root, everybody in the same group, and then and everybody. I think that's right. Okay. And so now no one has permissions. And so now we see a different error. we see this access denied exception. So before, up here, right, we had this no such file exception. So just changing the permissions, right? This here, we had permissions to read it and write to it, and we had no problem. But here, if I just remove the permissions, we had access denied. Okay. And then trying to use something that's the wrong input. So this is a little bit harder to do. But let's, for example, try to parse an integer from a string. So normal behavior, if I was to do this properly, right, I have like the number 5, and I try to parse it as an integer. There we go. It's now an integer. So this whole expression here is going to be a number. So I can easily say like -1, and I'm going to get 4, right? It's going to work fine. But if I try to pass it in something that's not valid, something that isn't a number, like meh, we see this number format exception. And so it's a very specific and unique exception for this case. But a lot of other things can use this exception. And so, for example, if you were writing a class and you had an instance where you wanted to tell somebody that, hey, the format that they gave, the numerical format that they gave wasn't proper, and the program won't be able to handle that, you would throw this particular error. It's a lot better to use off-the-shelf exceptions than to make your own. Sometimes it makes sense to make your own if you're doing something that's truly unique, but I think that there's a lot of exceptions that exist that covers 90-98% of what you want to do. So those were the exceptions that we had mentioned in class, and that's actually or in session the last 2 times. So yeah, so that's and this is how we would throw them, and this is what they would look like. So in this case, we're using the J shell, the REPL. But if this happened, if you had put this in the middle of your class file, in your Java file, your program would have stopped at this point because nowhere did we catch this exception. This exception would have been fatal to our program. So after we take a look at some of the things that's offered, some of the exceptions that's offered as part of Java that's just built in, we'll take a look at how would we keep going from this point as opposed to just stopping immediately. So let's look at these guys. So here's one of the exceptions. So this is Java lang exception. And so, for example, if there was a agent load exception, for example, right, this is sort of virtual machine stuff, but maybe you wanted to use agent load exception as maybe you were writing some kind of GUI, and the GUI wasn't able to load, but the backend was. So maybe you have your console application works perfectly fine, but then you have an agent that connects to that console that's like a graphical thing that has buttons and things that you can click, but for some reason it's not able to load properly. Maybe it has a configuration file for the layout of the buttons, and there was something wrong with it. Maybe this might be an exception that you might throw. And actually, let's look at just throwable. So you may have seen this, right? Whenever your program does something bad, you see this get stack trace. And what this is, it's essentially just listing out where things had crashed or where things had gone bad. So this here is a stack trace. And actually, yeah, here's a better example of the stack trace. So if, for example, you were using a lot of your classes, you would see like if you had called a class, like one of your classes, and then it had called another class and whatnot, you would see those, you would see them here. So you'd see like your class name and then what line called the next thing, your class name, what called what got called. And so what's nice is that if, for example, you did something in main called a method that then called a method that's a member of a class, and then it calls a helper function, 4 of these lines would be yours, and it would allow you to trace the stack trace. It would allow you to figure out who called what, when, where, and that's going to help you sort of narrow down where things had gone wrong. Sometimes you'll accidentally leave a call to something, and the stack trace is nice because it'll show you what line it called your method or whatever. Yeah, so that's very useful in this case because we're just using the J shell. Nothing here is any classes that we made, but we called the scanner, right? We in this line here where we're using the scanner and we were passing it this path of, then on the line 718 of the scanner class, we saw that it was dealing with this file's input stream because we were using a file. This here as a file. So path of this piece returned fine. This gave the file path of this file, and that exists. Even if a file doesn't exist, you can have a path to a file that doesn't exist because maybe you wanted to create the file, so you need the path for it to be able to create the file. So path of this piece returns perfectly fine, and so it essentially returns a file where a file would live, and so this new input stream of files is gonna be the thing that isn't so happy, and we're gonna see it. We're gonna see as it's trying to read it, this new byte channel, and then you see all these breathe throws. So there's all these things that are catching and are sort of trickling up or down depending on how you view it. Yeah, so if you had written your own main and classes, you'd see a few of these lines be your own code, and that's going to help you narrow things down. Okay, so back to so that's what a stack trace is. A stack trace is this stuff here. Yeah. Okay. Cool. Yeah. So here's a list of some of the exceptions, and fortunately they have it relatively compact. So let's just open this up, and I'm just going to make it look a little bit prettier. Okay. So here's just a a small sampling of these exceptions. Just formatted them so we could actually read them one at a time. Let's just pick one. So here we go, an AWT exception. So AWT is a graphical interface for like viewing stuff. So that's like the buttons and interactive things. You could have like bouncing objects all over the place. So this is just a generalized AWT exception. So this was just that something in that graphical environment went bad. So that happens fairly frequently. Graphical interfaces are very hard to do and are very prone to having exceptions because you're having to maintain both a front end and a back end. And so sometimes the back end, the thing that's supplying it, with information passes, maybe it's been updated, but the front piece hasn't been updated to match whatever the new thing is. And so very commonly you see exceptions because of that. Okay. Trying to pick out some good ones. We're probably going to see more stuff in the runtime exception that's going to be more applicable to the kind of stuff that we see. So yeah, here, parse exception. So this would be a really good exception to throw anytime you're reading through data, whether it's user data that's been typed in or a file that you've opened that's supposed to match a specific format. If you've detected that it didn't, that it's not the proper format, and you have no way of recovering from that, like it's just like maybe you open a corrupted file and you know that it's a corrupted file, you would probably throw in or expect to see thrown a parse exception. So there's an example there. And so yeah, a lot of yeah, like the audio file exception, unsupported file. So if you were missing a codec, that's essentially a way to interpret or a way that sound is encoded. If you don't know how to encode it, then you might throw this unsupported audio file exception, things like that. Or yeah, here we go, XML Parse Exception. So XML is a descriptive language for how to lay things out, and that's how we use it in Java. But really, any kind of data can be stored in XML. XML looks very much like HTML. So it looks something like this gobbledygook here. XML does. And so this would be, so up above we had a parse exception. Well, if you were trying to parse an XML file and you detected that it made some kind of violation, like it forgot to close something, it had an open and a close. If it was missing the close, you might throw this parse exception. Yeah, so let's look at something that we're going to see a little bit more, which will be the runtime exceptions. Okay. All right. And you'll notice that a lot of the that Java things inherit from, so like we have this get stack trace. So that everything inherits from in Java. So everything that we had in an exception, we have in runtime exception. And some things are overloaded so that they provide a little bit more useful information. And so in Java, everything, I'm using the word everything in quotes, everything that we're going to use inherits from object. There's a company that I worked for that they essentially had rewritten object to be called JUnit, or well, there was a company called Bouncy Castle that had rewritten object, and they were using it as part of their product because they wanted all of their objects to have a little bit different properties to be more secure. But in general, everything in the normal Java API is going to inherit from object. So everything that object has, all of these attributes that it has, this clone, equals, finalize, get class, hash code, notify all, toString, and we've seen things that don't, we can always call toString, or we can always try to print something out in Java, and what will happen is that the default toString just prints out the spot in the Java virtual machine that object lives in. What's cool though is that you can overload it. You can essentially write a new toString and make it do something more useful that makes sense in the scope of your object or your class. wait, and yeah. So everything in Java that we're going to use has all of these. And so throwable and exception, everything that's in these two, we also have in this runtime exception as well. Okay, so you're right. So let's take a look at these guys. All right, so just do that. Okay, so we see arithmetic exception. Well, okay, so we have seen that divide by 0 throws an example of this arithmetic exception. And probably if we were to look at arithmetic exception, we could see other subclasses. Well, actually, let's try it out. Let's open up the J shell and see what exception. So 1 divided by 0. So we see, oh, okay, yeah, so divide by 0. So arithmetic exception, so that's actually what threw, was this arithmetic. But what's cool is that when they threw this exception, they had a little note, divide by 0. So the exception can actually, when you catch the exception, you can actually look at the some of the variables that you were using, and to determine that it could look at this variable, and it could look at this. I mean, it could look at this operator and the operand, and it could then say divide by 0. Okay. So cannot redo, cannot undo. Well, I mean, a lot of the IDEs that we use. So, for example, Eclipse probably uses these exceptions. Cannot redo and cannot undo. Let's take a look. So we saw some of these file system not found exception. So we saw some of the file stuff. So no such file exception. Oh, and actually that lives in file. That particular exception lives in NIO and file. So that would be more of if you were trying to do something like you plugged in a flash drive and you're trying to open the flash drive, that you would probably you would see this file system not found. Or if you were trying to re-add that, like say that you plugged in a flash drive and it existed already, and you're trying to open it again, even though you already had a connection to it, you might get an exception like this. Let's see what else. Oh, there you go, unsupported operation exception. So if somebody was trying to call something in your code that you didn't support, you might throw that exception. Just, yeah. Maybe you had flags that people could pass in. You know, like when you say like, let's just like when you say ls, right? When I run this program, versus when I say ls-l, right? That changes its behavior. But maybe somebody typed in something that wasn't a valid thing. You need to be able to catch that invalid option. So yeah, there you go. Yeah, so there's a few that you have that you could work with. Let's take a look at just the Java lang exceptions. And so this is just a good exercise just to go through also yourself. Like whenever you are thinking about making a new exception, just look through the API to see if somebody's already made it. Oh, we already looked at this one. Let's see, I want to look at, I specifically wanted to look at, so let's look at the array index out of bounds. Tons of stuff blocking. Where's the search? Oh, and this is the old Java. Okay. Yeah, so we see that these look very familiar. This is all the stuff that's inherited from object. This is all the stuff that it's inherited from throwable. So we have this get stack trace and print stack trace and whatnot. We have the get cause. So this is how we're able to use it and understand the exceptions that got thrown that we'll see when we hop over in our catching stuff. Yeah, and so array index out of bounds extends array index out of bounds, right? So index out of bounds is more generalized. So, for example, maybe you weren't using an array. Maybe you were using something called an array list. That is it's a variable size array, or that's what we tell ourselves. But maybe you were making something that maybe you had used 4 variables, and you weren't using an array, but you could only store 4 things, and you were full, and somebody tried to go and tell you to put something in the 5th spot, but you only had 4 spots, you might throw this index out of bounds exception. So this is a more generalized version than this array index out of bounds, because this array index out of bounds is specifically only for when we're working with arrays. And maybe you don't want to reveal that you're using an array when you're writing your code. And so it might make more sense just throw an index out of bounds. Okay, so that's enough looking at exceptions. So let's look at exceptions. Okay, so you saw something very similar to this from Jeff in the last class, except there was a set of parentheses right here, and there was something in the parentheses that could crash. What you can also do is you can have this whole block, this whole try block, with stuff that could throw exceptions. And both camps are totally fine. If there's only one line that has to do with something, or you want to create something and have it stick around, right? You might do it outside, or you might, yeah. Scope is an important thing to look at when you're working with stuff here. So, if you need access to something here, but it's only created inside this block, then you need to define it up here. So for example, if I made an integer, so let's just start with our starter code. I think there's supposed to be a C somewhere in there, but whatever. Okay, so we're gonna drop in our starter code, and then we're going to drop in that stuff. Okay, so this is just a generalized, so right now this catch is a general exception. So anything that wasn't specified before, and you can think of it as a filter. You can keep adding more and more catches to explain more and more of the problem. So we're just going to say general. And actually, let me make this a little bit bigger. So if we go back to this this guy here, so let's dump in the code that threw these exceptions, and then we'll do them one at a time. So we had seen that, for example, doing this, right, would throw that this line here would throw that exception. And so what we can do is we can include that so we can catch it. Actually, I don't remember if you have to include it or not. So let's comment that out and then see if we need it or not. So then we could say so this is the exception here. And actually, I can probably chuck that. Okay, so let's see if this compiles. If I haven't goofed somewhere, I think I've missed semicolon somewhere. Maybe they changed that syntax. Catch exception E. Yeah, no, that was right. Try without catch and finally. Oh, right, I have an extra. Count your curly boys. Okay. All right. Okay. Sorry about that. So yeah, I just had forgotten to write this catch here. And then also, we don't need this file path here. We can just check that file path there and get rid of sure. Something like that. Okay, so now let's see if we can compile. All right. Okay, so now if we were to run, there we go. We get our custom, or a little custom message that we had written. And that if now we did something down here, system.out.print. There we go. Okay, so if we had add a println, there we go. We see this still alive. So otherwise, if we had removed this, so now we're just now we would not expect the still alive to print out. See, if we just get that, we just get the normal stack trace. This is from the Java virtual machine. It's printing out the stack trace for us. As opposed to here, this is us printing it out with our catch, and then we're still alive and we're still able to do stuff. Oh, and we didn't need to import. All right, greetings. Greetings.
Hi, Carter.
We're playing with exceptions right now.
Okay.
All right. So yeah, we saw that we didn't need to import the exception if we're catching it, and we saw that the array index out of bounds, that we were catching that when we were running it, and that this general error won't be triggered if the thing up above ran. And you can think of just like the if else ifs, that there are filters that if it's caught up above, that if it's handled up above, that we don't see it below. But we can always, have one of these other exceptions that we've been working with. So let's go back to the example here. Let's try to open a file that doesn't exist, and then a file that we don't have any permissions for. So let's do that. So if we just grab the code that we were using earlier, so we need the path and we need the scanner. So we already have the scanner. So let's import the path. This allows us to be able to actually point to the file, and we'll stick it right here. And so we had left the file. This file exists right now, but we had left the file in a state where we didn't have any permissions to read it. So right now, we don't have a catch that specifically catches the no permissions, but this one down here is the general error. So you should always have this here if you are in main and want to just make sure that maybe if you've missed catching an exception, that you always catch it and that maybe you log it. Maybe you don't have access to the console that your program is running in to print stuff out, and that part of the exception handling is you want to write to a file some information about how the program crashed. That way, if a customer calls you up angrily and says, "Hey, your program doesn't work," you could say, "Hey, could you open this file, or could you send me this file?" And so that's a really good reason to have a generalized exception, to be able to handle those cases that you weren't expecting. So yeah, so right now we expect that this here is going to throw a no permissions exception. And so what's going to happen is that this array index out of bounds is not going to catch it. Those aren't compatible, but this general error should. All right, compiles, it must be good. And so there we go. Oh, right. So we are still throwing, we're still doing this. So let's comment that out. All right. And so there we go. We see this general error and we're still alive. That we caught the error of the no such file. Okay, so that means that my computer actually went up and cleaned up that file. It was pretty quick. It noticed I wasn't using it. Temp lives in my system memory, not on my hard drive. So so let's go, and so this is the no such file exception. So let's handle that. Let's handle that exception first. Okay. And so right now, all of these are looking fairly similar, but you might want to do different things. For example, in this case of the no such file exception, you might ask the user, you might tell the user, hey, that file doesn't exist. Did you mean this other file? And you might give them suggestions. You might give them another chance to try to do, to try to use the proper file. So in the try catch, it's not just logging or printing out the fact that something had crashed, but you have an opportunity to actually recover no such file exception. But you have an opportunity to actually recover from it, or maybe loading a default. Oh, cannot find symbol. No such file exception. Did I misspell something? Oh, yeah. So this one I probably have to port. All right. Yeah. So that one I had to include because it was because the NIO file NIO is a different path than util. Because if we recall when we were looking at the exceptions, this index out of bounds exception, and we can even look at the stack trace if we go up further enough, that lives in the Java lang. And so we have Java lang, but we didn't have this NIO, so we just included it. So that's going to allow us. So yeah, that's going to allow us to handle this exception. Okay. So let's compile it. All right. And there we go. So we caught it. This is our message that we wrote to ourselves, and we're still alive. So now let's go make that file. Oh, right, because we're on Jeff's server now. That's why that file's gone. Okay. We're going to touch that file, and then let's run the program and see. We don't throw any exception, and we just see it's still alive. So now let's remove the permissions. Chmod 000. So this is changing this. You don't have to know this, but this is changing the permissions of this file so that nobody has access to it in any way. And so now if we run it, see, now we get an access denied exception, and the general error was what caught that one this time. So we could go in and we could add in that exception as well. And so the idea being is that there's sort of two camps. You could throw everything together. So in this case, notice how this line here specifically dealt with just this exception here. So I could surround this one line with the try catch, and then all the subsequent lines. So like for this guy here, we're going to have the two exceptions. So you can have a ton of try catches all over the place, like multiple copies of a try catch. It's specifically this one line right here has its own try catch that's surrounding it. And that this one then has the other two. And maybe you tack all of them with this general error. So actually this one would have two. It would have the array index out of bounds, and it would have the general error. And then the scanner one, where we're dealing with a file, you would have the access denied, no such file, and just the general exception. So we're going to say ADE. Oops. And oh right, because we need to include that one. So if I am really lazy, you can just put an asterisk here, and then that will import everything. So an asterisk is an expansion character. It essentially says all of those things. That way I don't have to include each individual one. So now we're including two exceptions from the Java NIO file class. Okay, so now if I run it, see, we see our access denied exception that we throw, and we are still alive. So there we go. That's how to do try catches. And Jeff showed us a little bit a different syntax too. He had put something in here that essentially allowed us to create a variable, and that would the thing that would be right here, we would expect it to crash all the time. Yeah, any questions about exceptions? Okay, so yeah, did a little check-in, talked a good amount of exceptions, and then showed how to catch the exceptions. That's what I did today, and the recording will be posted on YouTube when it's finished processing. Zoom is all over the place when it's with processing videos. Sometimes it's an hour, sometimes it's a day. So.
Thanks, Carter.
Yep. And then I'm gonna hop over to class.
Okay, see you there.
Yep, see you there.